Okay, the session is being recorded. Okay, this is what we are going to do today. We will try to focus on the abstract algebra group. It's a continuation from the last week's online lecture. The videos associated with this chapter also has been published. You can slowly take a look it over and over again. Before I start this, I would like to know if there is any question that you would like to ask first before I start the session. Okay, I repeat. Is there any question that you would like to ask before I start the session? No? Okay, I suppose I will start now. Can someone please highlight me, the one who followed the lecture last week? Would you please remind me back where did I stop? To the one who entered my online lecture last week, would you remind me where I stopped last week? Ada tak yang ingat? Hello? Oi!
Saya tak datang, saya tak ada lecture lepas.
Yang datang lah. Who entered my lecture last week, can you please at least give me some basic idea where did I stop? If not, I will maybe repeat most of the thing that we'll say today. Come on. Saya tak nak ajar lama sangat. Saya tak nak ulang balik. Apa ni? UN. Kan bagus ada orang jawab. Okay. I already teach you UN. Okay, that's good. So UN settle is a integer with positive integer greater than or equal to 1, of course, which is relatively prime with n, and it is also modulo n. Okay, so we already covered this. That's good. So maybe I can directly go to here. Okay, semi-group and monoid. Okay, ada lagi nak masuk ni. Okay, for the group, okay, in order to be a group, it must be closed, associative, it has identity. Just a refreshment, because every time I need to mention this over and over again, okay? So for group, okay, if it satisfies 4 of the properties, we call it a group. And if it satisfies commutative, then we call it abelian group. Okay, for semi-group and monoid, it's very simple. Semi-group, as the name implies, is the half of the group. So you can imagine like this. A semi-group is any G that is given. If it satisfies 2 of this condition, we can declare it as a semi-group already. Semi-group might not necessarily be a group, but a group definitely be a semi-group, okay? If it satisfies closed associative up until identity, we call it a monoid. And if it satisfies 4, we call it a group. You see, semi-group is a subgroup of monoid. Monoid is a subgroup of a group. And lastly, if it satisfies all, we call it abelian group. Okay, the fundamentals, the properties. Now, I would like to repeat the things that you might forget about the close, okay? Let G be any binary operation, okay? G is the domain of set. The symbol star there represents as binary operation. Close means that for every two elements in the given domain set, A binary operation with B will produce new element. And this new element must also contains in the same set of G. Okay? Just to remind back, kalau lupa lah. Ni asas dia. For associative, for every three elements in G, it behaves like this. Okay? You do the first two, it will be equal with if you do the next two. This is the definition of associative. Identity, for every element in G, there exists a unique identity, namely E, also in the same set of G such that it behaves this way. AE equals to EA, you get back A. Inilah identity. And if you have identity, you might have an inverse. An inverse is defined as for every element in G, there exists an inverse in the G such that A, the binary operation with inverse equals to inverse binary operation A, you get E. Okay. In order for you to master this definition, the properties, you boleh practice macam ni. You can practice like this. Every time you try to recall back a proper definition. So that's why I like to recall it even to myself. That's why I can master these properties, each of the properties. Lastly, commutative. Commutative behaves like this. For every two elements in G, what happens is that A binary operation of B equals to B binary operation with A. Alright. Very, the definition is very straightforward. However, the implementation is plenty. Okay. We already know how to prove a group and abelian group. And also monoid, you just prove three properties, semi-group, two properties. Sekarang ni saya nak fokus balik kepada subgroup. Okay, subgroup, there is a question for subgroup, I suppose, in the assignment. I don't remember what is the question, by the way, but that's fine. Let's try to look a simple question first, like this. Okay. This one I will delete the properties. Okay. Suppose I have a group G, which is defined. Okay, this time I will involve a proper Z. Z, I take of Z4 under addition, and then I have a set H, which is defined as Z 3 star. Okay. All right. Right now we have one group and one claimed subgroup. Okay. This is what I meant. G consists of 0, 1, 2, 3. Ini G kita, Z4 kita. Sorry. Z4 teruslah saya tulis nanti pening. Z4 consists of this element 0, 1, 2, 3. And Z3 star, beza dengan star, the difference with the star is only it does not include 0. 1, 2, up until n-1. So 3 is not included. Okay. In order to be H to be a subgroup of G, we must check first whether H is a subset of G. And this is clear that Z3 is a subset of Z4. Z3 star. Okay. This condition has been satisfied. First, this is the fundamental thing that need to be tested first. Subgroup, ini set this is a set, terminology dalam set. A subgroup, symbol dia like this. It happens to be a subgroup of G. In order for you to determine whether it's a subgroup of G, you have two kind of tests. The first one is a one step and the second one is two step. I always like to teach my student two step first because two step, although it is longer, but it is more, structured. Dia pecah, it divides the properties into two clear conditions. So you can refer to the two step here, sini This one first. If you look there are two properties that needs to be satisfied. The first one is that, suppose we define G be a group and H is a subset of G, which has been satisfied for this example. It is a subgroup if it is closed in H under binary operation of G. So we start first by showing what it means, two-step subgroup. Okay, I redefine back, okay. Keyword dia kat sini is closed. Tapi it's not the same closure. It means that for every two element in H, A binary operation with B will produce C. This C is in H under binary operation of G. The difference with the first definition of closure, because this time we involve two sets, H and G. To determine whether H is a subgroup of G, it must be closed in H. Tetapi, however, under binary operation of G. Beza tu. It's different. It's closed in H, but under binary operation of G. Okay? For the second one, the keyword there is inverse. For every element in H, there exists the inverse in H under binary operation of G again. If it satisfies these two conditions, the close in H under binary operation of G, and also it has inverse which is in H under binary operation of G, then we can say that H is a subgroup of G. Now let's try to implement this example. Alright, this time we have H which is defined as Z3 star and G Z4. Yang mana saya dah tunjuk H is definitely a subset of G. Now the question right now, is it the subset of G? A subgroup of G, okay? We need to have a Cayley table for Z3 star. Right. Okay. Binary operation of G, of H, 1, 2, 1, 2. Okay. Bear in mind, this is not similar with the normal Z3 star. The Z3, the binary operation that you will do right now is under binary operation of G. So binary operation of G ni apa? adalah plus modulo 4. Ni. Plus, you add up the element modulo 4. That is the binary operation of G. Therefore, in order for me to develop this H punya Kelly table, which is Z3 star, the element from Z3 star, this time you apply the binary operation of G. So 1 plus 1, 2. 2 modulo 4. 2. 1 plus 2, 3. 3 modulo 4. 3. To those of you who already master actually how to do develop the Cayley table, this is not under binary operation of Z3 star. Kalau binary operation of Z3 star, under addition, this one 1 plus 1 2, 2 mod 3 kat sini. Jadi 2. 1 plus 2 3, 3 mod 3, 0. It's different from this one, different. Because this one under binary operation of G, which is modulo 4. 2 plus 1, 3, 3 mod 4 is 3. 2 plus 2, 4, 4 mod 4 is 0, this one. Okay. So let me finish the original Z3 star, punya kalau dia single saja. This one will be 0, this one will be 2 times 2, 4, 4 mod 3, 1. Okay. Under this context, to sum up with, in order for you to develop the Cayley table, you must check under binary operation of G, not the original binary operation of H. So that's why it's different, different. Okay, we don't try to attempt whether it's a subgroup or not yet. Kita tak buat lagi, okay? Right now, we want to actually check whether it is closed or not. This is the solution. It must be closed in H under binary operation of G. That's why we develop the Cayley table. Right now, you see in the element produced in this Cayley table, is it closed? Kalau closed, it means that all element must be contained in H. In this case, our H is Z3. Z3 adalah 1, 2, Z3 star. My question right now is that does all elements here is an element in Z3 star? No, definitely, clear. Okay, that's why Cayley table kena betul dulu. Cayley table kena tahu buat. It is not closed. Ya, ni silap ni. 2 tambah 4, 1, 1, 2, 2, 3, 4, 4, 3, okay. Alright, so 2, 3, kalau bahagian close ini, you can put a conclusion there. It is not closed. H is not closed, Sekejap. H is not closed under binary operation of G because contoh dia saya ambil, okay, because 3 is not an element of Z3 star. As simple as that. You can also take 0. 0 is not an element of Z3 star. It's still the same conclusion at the end. For the inverse, okay, right now we are talking about inverse. Inverse, you must mention what is the inverse for 1, what is the inverse for 2. Apa dia? Okay. For the inverse, you need to have identity first. Right now, in this Cayley table, saya besarkan balik, sorry makin kecil. Okay. Alright, in this case, ada tak identity? 1 binary operation with what? On the top here, you get back 1. For 2 also the same question, 2 binary operation with what? You get back 2. Dalam ni, in this scalar table, there does not exist such E that operates with every element of 1 that will produce 1 back. There is no element of E that binary operation with 2 you get back 2. Tak ada. There is no such identity. As my conclusion right now, I can say that as identity does not exist, H, as my conclusion, inverse also does not exist in H. Cukup. Okay. As for this question, for the case of whether Z3 star is a subgroup of Z4 under addition, H is not a subgroup of G because it fails at both conditions dictated by two-step subgroup test. Okay, I let you think the idea for a while. Should you have any question, you may ask. Buka suara pun tak apa. If you are not comfortable on how to write the question in chat, I'm okay that if you ask me directly using your voice. Lagi senang kadang-kadang. You can ask in English, in Malay also can. Malaysia. 1 minute. Okay, Nick Adli Afif, Nick Muhammad Kamil, he asked that a closed group can only be shown by using Cayley table only. My answer is no. Cayley table can only be used for the case of finite Zn, integer modulo n, integer modulo n star, Zn star, and also Un. If the question asks if the G, given a G a set of integer saja, bukannya integer modulo n, itu tak boleh guna Cayley table. Cayley table hanya untuk case of Zn, Zn star dan also Un. Dia modulo-modulo saja yang kita guna Cayley table ni. Kalau tak ada, for example, addition of integer, subtraction of integer, itu tak boleh. Okay, because Nick asked like this, I want to show you another example still in the subgroup case. Okay, this is an example of a subgroup case. Kita still buat subgroup tapi kali ni tak guna Cayley table. Contoh dia macam ni. G is Z under plus. Ini integer saja. H apa? H I define a very small one. H I define as a set of a finite set. Saya buat 1, 2, 3. Okay. Kecil je. Determine whether this example H is a subgroup of G. Ini mungkin senang dari tadi. This might be more easier to understand from the previous one. Okay, my question first. Okay, in order to determine whether H is a subgroup of G, adakah H is a subset kepada G? The first question that you need to see right now, G is a set of all integers. Okay, then definitely H is a subset of G. Ini clear. Baru kita boleh guna. Two step. Okay, two step subgroup test. Number 1, close tak? Okay, 1, 2, 3. Ni pun boleh guna Cayley table tapi saya tak nak guna. Tapi how to show that it not necessarily must use Cayley table for the case of a normal integer. Okay, it says here that A must be for every element, saya ulang balik. For every 2 element in H, A binary operation with B produce C, C is also in H under binary operation of G. Okay, macam mana nak apply kat sini? Macam ni. Kita ambil finite element sini. 1 plus 1. Kenapa saya guna plus? Plus is based on the binary operation of G, addition of integer. 1 plus 1 equals to 2. Is it close in H? 2 ni. 2 mestilah close in H. 1 plus 2, 3. Is it close in H? Also is in H. There is one problem though. 1 plus 3 equals to 4. This 4 is not in H. Nampak? Binary operation yang saya guna ni adalah binary operation G. Tambah. Tambah biasa tau. Bukan tambah modulo tau. Tambah biasa. That's why 1 tambah 3, 1 plus 3 becomes 4. And this 4 is not an element in H. Counter example, this counter example alone, I can say that H is not close. So this still not close. Okay. How about for the identity? Identity. No, inverse. For every A in H, there must exist some inverse is also in H under the context of binary operation of G. Okay, this question is interesting because as you can see there in this H, apakah 1 plus 1 inverse dapat E? So kita kena tahu dulu apakah itu E, kan? Okay, E apa dia? Ada tak 1 plus E, you get back 1 here. Jangan lupa, E must also be in H. Okay. 1 plus E dapat balik 1. Ada tak dalam H ni? Tak ada. Because identity must be 0, right? Okay. For the addition, I think I mentioned in my video lecture, recorded video lecture, the addition identity always 0. The identity for multiplication, also known as unity, is always 1. In this case, identity does not exist. As identity not exist in H, inverse also not exist. Okay, based on these two arguments alone, I can say that for this case H 1, 2, 3, a finite set, H is still not a subgroup of G. Ada addition of integer. Tak ada. Okay, let this idea sing. Master the properties, please. If you master the properties, you can answer any of the question if you think carefully. Okay. Katakan saya ubah soalan sikit. Okay, ni soalan tadi dah siap lah. Okay, the solution is already finished. I would like to change the question a little bit. Kepada darab. Okay, this time is multiply. H is also 1, 2, 3 jugalah. 1, 2, 3. And let's see how we change the binary operation here will affect the solution below. Okay, saya padam kejap. Bagi saya masa padam kejap. Kalau dalam video lecture, I can pause. This one cannot. Alah, terpadam. Okay, ni apa dia? For every element in H. Okay. Right now, I change the question into multiply. Okay, multiplication. multiplication of a simple integer, not an integer modulo n again. This time, the same principle, H is a subset of G. Sama je. But the difference right now is here, we start here. For every 2 element in H, A binary operation will produce C, C must also be in H. 1 times 1, 1. 1 is in H. 1 times 2, 2 also in H. And 1 times 3 is also 3 in H. No problem here, except when you arrive at this particular point. 2 times 1 is 2, is in H. 2 times 2 is 4, is not in H. For the case of multiplication, still H is not closed because it will produce an element, new element of C which is not contained in H under binary operation of G. H is not closed. Okay? When we arrive here, the concept of inverse, where you need to find the inverse whether it exists in H or not, you must have identity. And this time, 1 times E equals to E times 1, you get back 1. Ada tak? 2 times E equals to E times 2, you get back 2. 3 times E equals to E times 3, you get back 3. Ada tak E tu? Sekejap Naresh, nanti saya jawab soalan awak. Okay. E is 1. Okay. Right now, persoalan dia, we need to check whether the inverse exists in H. Okay, tengok Right now it's confirmed to be 1. Ada tak 1 inverse? 1 times 1 inverse sama dengan 1 inverse times 1, you get back 1. Okay, dalam kes ni 1 inverse is 1. Ada. 1 pun dalam H. 1, 2 times 2 inverse sama dengan 2 inverse times 2 dapat balik 1. Apakah 2 inverse tersebut? The 2 inverse will be 1 over 2. And 1 over 2 is not an element in H. You tengok H. H 1, 2, 3, 1, 2, 3. There is no 1, 2. Although the inverse of 1 exists, the inverse for 2 does not exist. It violates this principle that for every element in H, there must be its inverse. 2 inverse does not exist. Okay? So as my further, 2 inverse not exist as well. You can verify also that the 3 inverse does not exist as well in H under binary operation of G. As my last conclusion again, H is not a subgroup of G. No need Cayley table. Thank you for the question. I tried to answer Naresh's question. Naresh asked, if the question has identity but no inverse, can we write identity exists but inverse does not exist? Okay, I assume that your question, Naresh, is about subgroup. Okay, you can say identity exists but inverse does not exist, no problem. But it still does not prove that it satisfies the second condition for two-step subgroup test. Tak ada masalah. You can tell the identity exists, but that's not the point. The point is that whether the inverse exists. Right now, if it has identity but still no inverse, it does not show that it will be a subgroup. Okay, a very good interaction today because this chapter is a little bit hard. So that's why you need to understand so much, then you can answer. You cannot just listen and read the proof. My advice to you for this chapter, when you get the question, of course try to understand the question first, master the properties, and you try to write back your argument on your own. You can look at my proof and my solution, but it cannot show that you understand. Okay, some of the group exists in this slide. I know some of you worried about this real number. Okay, apa ni? Z over NZ apa semua. Okay, let me clarify you this fact first before you start to worry. It's good for you to listen for this online lecture today. This slide is made by my friend Dr. Muhammad Syam. Dr. Muhammad Syam, when he tried to develop the slide for this subject, specifically for this chapter, he does not focus on integer. Okay, he's a pure mathematician and apparently he is an expert in group theory. This is group theory. Dia pakar dalam bidang tu. Okay, that's why some of his example is a little bit advanced for you guys. This slide is made before the first batch of DMA, so that's why he includes many of the examples which is not suitable for you guys. For under my supervision, when I coordinate this subject, I will focus more on the set of integer. Kalau you tak tahu integer, habislah. Tapi because this discrete mathematics, we talk about integer from chapter 1, chapter 2 pun banyak integer. So don't worry too much. Focus more on the set of G that I taught in the video lecture. Okay? Apa yang saya dah ajar dalam video lecture ialah G. Contoh Contoh G. Contoh, example. G can be a set of Z. Z is integer. Boleh juga jadi Zn, integer modulo n. Zn star, integer, excluding 0, modulo n. Un, walaupun huruf U this time, walaupun kali ni huruf U means integer which is relatively pairwise. So tak ada masalah dengan huruf U kali ni. A special in the assignment and also I teach in the class actually is about the matrix M2 with the input of integer. This is 2 by 2 matrix with integer as the input. Semua integer saya ajar. Nanti you tulis balik lah. Ni integer. Integer greater than 0 modulo n. Tak lengkap. Integer greater than 0 but less than n. Modulo n. This one integer greater than 0, less than n modulo n. This one integer relatively pairwise. Panjangnya. Pairwise with n and it must be larger than 0, less than n, mod n. Ini je yang saya ajar. Okay. However, this is G, baru G. When we say G, kita tak mention lagi dia punya binary operation. Okay, so in my question, I can always change the G and I can always change the binary operation. Binary operation, for example, plus, okay, subtraction, multiplication, division. Yang saya ajarlah setakat ni. It can also be an extra as a union. Intersection pun boleh. This one apa ni? Mutually exclusive. Also can for advanced binary operation. Alright. I want to take a break for 2 minutes please. Two minutes break. Okay, we continue back. We try to finish this at 2:15. We start at 1:10 just now. We try to the latest one that we finish at 2:15. Okay, Naresh asked me, can I give an example for metric question? Sure, why not? Okay, ada soalan kat sini. Exercise 5.4. Prove that H is a subgroup of G. Okay, if you can know how to play with this, how to, apa ayat dia? How to process the idea of producing the element of H, then you can do this. Tak kisahlah soalan tu subgroup or group, tak ada masalah. But the basic binary operation must be there first. So Naresh, I will answer your question right now by this example 5.4. Okay. The question shows that 2 by 2 matrix where the input element A, B, C, D must be integer. Okay. So G is given as A, B, C, D. Syarat dia, the condition, A, B, C, D is an integer. Okay, tutup. Binary operation dia adalah under addition. Okay. Before I start writing H at the later, you must recall back how to add up the matrix, right? Kalau tak tahu, if you don't know how to add up the matrix, then there will be a problem for this question. Okay. For H is a different representation. It must be A, B, C, D. A, B, C, D is of course in integer in this case. But however, one more condition is be put there, which is the summation of A plus B plus C plus D must be equal to 0. Okay. Of course, this H must be a subset of G because A plus B plus C plus D equals to 0. 0 pun adalah element of integer. So what my point is, this one must also be an integer for this to be 0. Okay. Right now, before we start answer this question, what are the example first of H? Okay. Kalau normal matrix for G, contoh, example of H. Saya letak, 1, 2, 3, 4. Is it in H? Dah tulis jawapan pula dah. Is it in H? Simple, we check. 1, 2, 3, 4 is in H, in Z. However, 1 plus 2 plus 3 plus 4 is not equal to 0. So it's not in H. Betul. Ni Adli betul Dia tidak, tapi kenapa? Okay. No is the conclusion, but why? Because 1 plus 2 plus 3 plus 4 is not in 0. So what are the examples such that A plus B plus C plus D equals to 0? Okay, this is one. 1, 0, 0, negative 1. Because 1, 0, negative 1 is integer. 1 plus 0 plus negative 1 is 0. So this is definitely in H. This is what we are trying to focus right now. Okay. We proceed to the original question. Prove that it is a subgroup. Okay. I still use two-step because two-step is much more clearer. Even I prefer two-step myself. Okay. It's been a long time since I do this example, so I try to write my answer nicely. Okay, for two-step, apa dia? The first one, it must be closed in H under binary operation of G. Saya suka tulis balik every time. Okay, for this case, you must add up the matrix. This time you have two matrices. The first is matrix A. A1, B1, C1, D1. This A1, B1, C1, D1, the condition is that A1 plus B1 plus C1 plus D1 mesti 0. Ini syarat dia. B pun second matrix A2, B2, C2, D2. The condition is that A2 plus B2 plus C2 plus D2 must be 0. Right now the question, you add up two elements. A plus B will produce some element of C. Is this C in H? Okay, soalan dia kan. Macam mana nak tambah matrix? A plus B, you add up the matrix like this. A1, B1, A2, C1, D1, you plus the second matrix, A2, B2, C2, D2. Betul? Okay. The condition is given at the top. A1 plus B1 plus C1, D1 must be 0. This one plus D1 must be 0. It will produce another matrix. Okay. Macam mana tambah matrix? You tambah dekat elemen ni, betul? Okay, B1 plus B2 here. C1 plus C2. D1 plus D2. Okay. This, to make my explanation simpler, I represents the summation of A1 plus B1. Apa ni? Kejap. sorry. Terkeliru saya. A1 plus A2 lah. A1 plus A2. B1 plus B2. Delete balik. Okay, C1 plus C2. D1 plus D2. Tutup. Okay, to make my explanation much more simpler, A1 plus A2 becomes new integer, right? Integer plus integer becomes another integer, let's say A3. B1 plus B2 I represent as B3, C3, D3. Tutup. The question right now is this new C is in H. And in order to answer that, this A3 plus B3 plus C3 plus D3 must also equal to 0. Because that is the condition of H. And obviously A3 is integer. Integer plus integer is integer. Okay, right now, we need to question this. Is this A3 plus B3 plus C3 plus D3 equals to 0? My argument is very simple. Because A1 plus, kita ambil dari sini this one, this condition and the further condition. A1 plus B1 plus C1 plus D1 equals to 0. And also A2 plus B2 plus C2 equals to 0. When we add up like this, kacau ni. Will also be 0 because this summation is 0, the first summation is 0, the second summation is 0. When you try to group them together, the summation will also be 0. That's why A3 plus B3 plus C3 plus D3 is also equals to 0. Therefore, this C, which contains new element of A3, B3, C3, D3 is in H. This is a good question actually. Okay, then as my conclusion, H is closed. I know some of you might argue with me right now because you need to understand this argument, this part of argument. Macam mana saya dapat ni? Okay. because based on my properties of mathematics, this is knowledge of mathematics. You try to add up two zeros together, 0 plus 0 is equivalent to 0. Because in this here, there exists 0 plus 0, and it will be equivalent to 0. Okay, let this idea sink for a while. Okay, is there any question regarding this? You kena masa. You must take some time to understand this section. I don't expect you all of you to understand this quickly. Okay. Right now, I want to answer for the case of the inverse. Ada tempat lagi? Ada. Okay. For the inverse part, the same. My matrix I represent as A, B, C, D. Kan ada daya tidur ni. Bangun-bangun, jangan tidur. A, B, C, D must be in integer. A plus B plus C plus D equals to 0. Okay. Original H. This time I take A as this matrix. The question right now, does the inverse matrix exist? Okay. Macam mana nak jawab? Okay. This is the condition of H given I represent as A. In order to answer inverse, you must know the identity first. And if you recall my video lecture, what is the identity for matrix addition? So, E, matrix E apa dia dulu? Okay. A, B, C, D tambah dengan identity matrix, it will equal commutatively ni you get back this A, B, C, D. Apakah dia E1, E2, E3, E4? Okay. The answer is very simple. Actually, the E is 0, 0, 0, 0. This is the identity for matrix addition. The identity for matrix multiplication is 1, 0, 0, 1. Okay, right now we have this idea. Try to think like this. What is A plus A inverse equal to A inverse plus A? You get back the identity matrix, which is 0, 0, 0, 0. I take A, B, C, D. I plus with the inverse A, B, C, D, inverse. Saya tulis satu belah je. I only write on one hand side. Equals to 0, 0, 0, 0. Okay. Bear in mind that this A plus B plus C plus D must also be 0. The question right now, we want to find what is the element inside here such that the summation of the elements inside here must also be 0. And it is found out that the identity matrix is just negative A, negative B, negative C, negative D. Because A plus negative A, you get 0. B plus negative B, you get 0. C plus negative C, you get 0. D plus negative D, you get 0. And because A plus B plus C plus D is 0, therefore negative A plus negative B plus negative C plus negative D is also 0. Okay, I write slowly takut tak nampak belakang ni. Negative A plus negative B plus negative C plus negative D is also equals to 0. Kan? Logic kan? If A plus B plus C plus D equals to 0, the negative A, negative B, negative C, negative D is also equals to 0, which indicates that the inverse exists in H. Apakah inverse dia? What is the inverse? The inverse is negative A, negative B, negative C and also negative D. Okay, saya tulis balik. It is negative A, negative B, negative C and negative D. There exists inverse this time for this question. There exists the inverse matrix for A1, for A. Inverse exists. As my conclusion, large conclusion is that H is a subgroup of G. The properties remain the same. The implementation of the question is not so. So I hope this example you can understand slowly. You can look at this video back. I hope I will not do the editing so much. I will try to upload it today. But for now, who are listening right now, you gain a competitive advantage as compared to the friend who are not here today. You sacrifice the today's holiday. Actually, I just know that today is holiday last week. I forget that our Agong changed the date. Kalau tak, saya hampir pergi office hari ni. Tapi tak apalah. Tak apalah. Don't worry, I still will do the lecture after Raya Haji. So the modus operandi is still the same. Who are free, you can listen to my lecture. Lecture is not I don't like to force my student to hear to my lecture, but if you want to listen, then also it's your own willpower. Okay. Any question regarding this exercise 5.4? It has one more question actually. What if 0 is replaced by 1? I just tell you the answer, the final conclusion is that H will not be a subgroup. The point is right now is whether you can put your argument nicely. Okay, let's see the whole argument for this question that I put. Oh, panjangnya. Wah, panjangnya. Okay, here there exists 8 marks inside here. I can ask this question in final exam, but 8 marks. Oh, wow. Imagine if you can understand this, you can easily get 8 marks. And also imagine if you cannot understand this, how many marks that you lose. Sorry, I hope you can answer. Alright, I try to finish by cyclic groups. Okay, what is a cyclic group? I will not rest. I will definitely finish this at cyclic group. Okay, kejap. Cyclic subgroup orang panggil. Sekejap. Okay, ring tak sempat lah. Okay, cyclic lambat pula. Keluarlah. Wah, I can see 8 marks already fly away. Mana you tahu soalan nampak keluar, Ong? Mana tahu soalan lagi senang? Mana tahu soalan lagi susah? You hilang 10 markah? Just joking. Okay, cyclic group. Okay. Don't worry about the things that not happen yet. Worry about the today's lesson first. Okay. Cyclic group in also named cyclic subgroup. Okay. A group G is known as a cyclic subgroup if there is an element A, blah, 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 G A to the power of N. Such an element A is called a generator of G. Oh, you dah nangis dah. Wow, so many alphabet. No understanding at all. This is how we understand. G A to the power of N. N is a positive integer. Not integer technically. Okay, let's start first with the definition of U5, and U5 contains 1, 2, 3, 4. Okay, the same thing that I will tell you after this is already in the video lecture, but this is a live interaction if you cannot understand how I produce it, okay? Normally, this is under multiplication, okay? So I write this clearly. This is a U5 under multiplication. My friend Dr. Sham always say to me, U5 is strictly for multiplication, but sometimes I change it to addition as well. No problem, eh? 1, 2, 3, 4. 1, 2, 3, 4. Binary operation of multiply. Multiply mode 5. 1 times 1, 1. 1 mode 5. 1, 2, 3, 4. 2, 4. 2 times 3, 6. 6 mode 5. 1. This will be 3. 3, 1. 9 mode 5, 4. 12 mode 5, 2. 4, 3, 2, 1. Okay, finish. How to generate is the question right now. Okay, what is the generator of, suppose that 1 is the generator, what it will produce? Okay, in this slide, it shows that the answer is only 1. But again, the idea on how to know whether it can produce only 1. A to the power of n represents like this. 1 to the power of 1. 1 to the power of 1 is 1. 1 to the power of 2 is equivalent to 1 to the power of 1. Binary operation with 1. Okay, so you look at the Cayley table. 1 binary operation with 1. Modulo 5. Don't forget, modulo 5. 1 times 1, 1. 1 modulo 5 is 1. 1 over 3, 1 to the power of 2, binary operation with 1. 1 binary operation 2, from the previous calculation, we get 1. 1 binary operation 1, still get 1, based on the Cayley table. And you follow the idea again, 1 over 4 is still 1. Because this is mode 5, definitely 1 to the power of 5 is equal to the 1 to the power of 1. So I think in my face-to-face lecture, number theory, I already mentioned this. Modulo, there is a cycle, and this is a cycle of 5. So it will repeat the pattern back. 1 will only generate 1, unfortunately, up until to the power of n. Okay. Now let's try to, okay, listen carefully after this, because 2, the answer is different. 2, how to generate the element? 2 to the power of 1 is 2. 2 to the power of 2 is 2 to the power of 1, binary operation with 2. 2 binary operation with 2 based on this Cayley table is 4 modulo 5. Don't forget modulo 5 is still 4. 2 to the power of 3 is 2 to the power of 2. Binary operation with 2 to the power of 1. Okay, this one I do one more step. 2 to the power of 2 is 4. 4 binary operation with 2. Dapat apa? Based on Cayley table, this is multiply mode 5. Bukannya 4 times 2, 8. Saya tahu. Semua tahu 4 kali 2, 8. Tapi ini adalah 4 kali 2, 8 mode 5. You get 3. 2 to the power of 4 is 2 to the power of 3, binary operation with 2. Therefore, based on the previous line, 2 to the power of 3 is 3. 3 binary operation with 2. Tengok Cayley table, dapat 1. You can proceed more, but like I said, it will repeat itself back. 2 to the power of 4, binary operation with 2 is equivalent to 1. Binary operation with 2, you get 2. I do one more to make sure that you believe me. 2 to the power of 6 is 2 to the power of 5. Binary operation with 2 is 2. Binary operation with 2, you get 4. You see the pattern there? 2, 4, 3, 1, 2, 4, 3, 1. Therefore, 2 will generate all elements in U5. Okay? Because it can generate all elements in U5 2 is known to be a generator. Okay. Okay, right now it's confirmed that 2 is one of the generator because, masuk generator adalah because it can generate all elements in U5. Therefore, this is existential quantifier. U5 under multiplication is cyclic subgroup. Again, because there exists a generator. Okay, you can verify 3 is also the generator, 4 is not the generator. Still does not deny the fact that this U5 is a cyclic subgroup. Very simple. Okay. Example 5.9, the solution is already there. There is no Cayley table. I advise you to do it back, the basic practice. And please verify on your own later that 1 can only generate 1 for your case of U8 under multiplication. 3 can only generate 3, 1. It does not generate 5 and 7. Same goes with 5, same goes with 7. Because there exists no generator, therefore U5 is not a cyclic subgroup. Okay. It's 2:15 right now. I think in the next lecture, I will mention about the center and centralizer before I proceed with the concept of ring. But please take some time to understand the properties of a group, abelian group, subgroup. If you manage to understand this, then we will shift to ring. So I give you 1 week for you to view my video lecture and do the assignment. The assignment, like I said, has already been extended. A question, Nick Adli, sila bertanya. If we only show that a group is not closed, can we declare it's not an abelian group? Very nice, Nick. Soalan ni saya selalu dapat. Okay. If the question, okay, boleh tengok soalan Nick. Nick asks us, if G is not closed, can we declare it? Declare it not abelian. Soalan ni bijak. Okay. Yes, actually, if it is not closed, you can declare it is not abelian. Because this is counter example. Abelian must satisfy all. However, if the first condition is not satisfied, by principle, yes, you are correct. We can declare it not abelian group. That's why in my question, I always add up this statement. Saya selalu bubuh. By checking all properties of abelian group. But if you have this disclaimer, this sentence, it states that if you found it is not closed, you still need to check for the second properties. You still need to check whether it's associative. You must check also if it has identity or not. Inverse and also commutative. By checking all properties. Kalau you tak jawab yang lain, maksudnya you kurang markah. So Nick, kalau dia tak cakap by checking all properties, jawab not closed dah cukup. However, if it includes by checking all properties, you kena jawab semua properties. Okay? Soalan lain? Okay, 1 minute before we end the lecture. It's a very nice session today. I feel very comfortable at my home. And also you at your home lah. Yeah, I hope you can appreciate the extra 1 week because it can help you so much for this today's online interactive lecture. And also based on my video, you can answer the question in the assignment. Assignment, yes, why not? Although it's individual, saya tak adalah cakap buang seorang-seorang, tak ada masalah. If you want to discuss, no problem, but just don't copy bulat-bulat, itu yang saya marah. Siapa tak marah? Itu maksudnya you tak belajar. Our intention of the lecturer is that we just want you to learn. Jangan terpaksa. Walaupun terpaksa pun, sabarlah. Please be patient. Try to learn it. Try to do it on your own after you manage to understand based on the discussion with your friend. And you might also ask me, no problem, tak ada masalah. Saya boleh bantu. I will not just give you a direct answer, right? Siapa kata assignment tak boleh tanya soalan? Sebab tu saya tukar assessment kamu semua kepada assignment. Sebab first of all, of course, I would like to minimize plagiarism, and also I can help you. The quiz you cannot ask, right? Assignment you can, but no one asked me until this point in the group as well. So I'm happy to do that, no problem. Kalau korang tak tanya, saya tak ada masalah, saya tak jawab. Okay, I hope it can help for your assignment. Try to learn this thing diligently. Try to minimize unethical behavior. Do this the right way. I hope that you can have extra months because your final exam will be at October, except for only one student. If no, I will end this lecture. Have a nice holiday. Selamat Hari Raya Adha to those of you who celebrate. Otherwise, happy holiday as well to those of you who not celebrate it. Thank you so much and goodbye.